So this week lab, you're going to build a soccer game. So we're going to take the smooth movement and we're going to upgrade that script to use the physics system. What those pieces are and whatnot, we'll talk about in a moment. You'll make a soccer ball. It will be basically a physics object, and then there's a soccer net. Don't worry about the pieces. There's a package that you're gonna add into this week, and that will have like the net and the pitch will be built for you, so you don't have to worry about that. All right. There are two built-in physics engines, and there's technically, I think, a third. I know PhysX was the original. I know they're moving to Havoc, I believe, and then they're using Box 2D for the 2D components. All right. The big thing I want to be clear about is that there is the 3D engine and there is the 2D engine components. And don't try and mix the 2D components are intended to have 2D at the end of them. Don't try and mix the 2D and 3D stuff. They don't work together. Just straight up don't work. They're just different systems altogether. So, all right. So collision Unity. So in order for a game object to use Unity's physics system, requires two components. One, the object has the collision. This defines the solid area of your object. Now the collision also could be the volume of the trigger as well. And at least one of the objects has to have a rigid body. And this provides control of an object's position through the Unity's physics simulation. It also says it is a physics object. We'll set up the ball first, and then we'll see that in action. And here is documentation on the rigid body. And the collider. Okay, so typically there is the update, there is fix update, late update. So there are different timing functions. So far we've used update and start. There is one for awake, which we'll use later on. Fix update is best to form physics updates here. So rigid body is a component. Let me see. So mass how heavy is 1 unit is 1 kilogram. Drag resistance applied to movement 0 is none. Angular drag, but this is applied to rotation. Use gravity, obvious. It's a checkbox. Is kinematic affected? Is not affected by Unity physics. Interpolate smoothing method for smoothing method for the smoothing of how the object's moved. Detection, how the collision is detected, and constraints, how physics is applied. In our case, we will be freezing a lot of times freezing rotation, and also sometimes freezing position. So for our rigid body moving character, we don't want it to move. We don't want the physics object to move the object in terms of rotation. We'll see why. And we don't want it to move it on the y-axis, which is up and down. We want to keep it on the x. This is, again, we're keeping it in the 2D plane at x and z. And here in rigid body API. All right. The change is linear velocity is what it's not just velocity, it's called linear velocity. We'll show that up. I will make a change into the slides. I will read up these slides reflecting that change, but we'll get that. So this is setting the direction and speed of the game object the rigid body is attached to. Again, it's both direction and speed. So it is your move direction times your move speed. Now, when using the velocity on the rigid body, you do not have to set time. You don't have to use time.delta time, because basically the physics system is taking that into account for you already. You're saying I'm moving in 50 miles an hour going north. Add force adds force to the game object attached to. Force mode has the default value, so it can be excluded. So you can, there's different modes you can use, but you don't have to use that. Checking for a component, and for us, we are using get component, and we can check this. There's two ways. So basically, again, here is RB rigid body game object get component of type rigid body, and this is again template code. So we can ask for other classes. You can ask for one of your script types, which is what we'll do later on. We'll talk about get component because there's multiple ways to use. Actually, I don't talk about this week, but there is other get components. There are multiple versions of this function for different purposes. But there are two ways we can do. And the first one, if RB is equal to null, we have no rigid body. And then we can do the exclamation point RB, and this is in Unity only, and with components. So with your, again, we saw this already with the devices. Devices are not components. They're actual C# objects. So that's why we had to write the code in this particular way, if RB is equal to null. Or not, in this case we said if RB is not equal to null. We did stuff. Again, we can also do if RB, do this code. But typically we say if we don't have something, we will exit out early. There is a require component. Do I have two versions? I do have two slides. I don't have. Let me bring up the script for this. So sometimes you can just say. So in this case, we have this right here. Now this is a attribute. This is we might also refer to as a metadata piece. And so this script requires the component type of rigid body. So you can look at. So if you want to make sure that this player script requires the game object to have a rigid body, you can add that to your script. And this is great for your artisan designers who don't realize they have to do stuff like that. And if the object doesn't have a rigid body when the script is added to it, it will add that component automatically for you. Again, great for your level designers and artists who might not know that they have to do something like that. Again, here is the rigid body, and here is on fix update, they're adding a force going up. Collider. Again, collider is basically the collision portion of is either the volume that is solid or the volume of a trigger. First thing is every collider has a is trigger value. So boxes, spheres, capsules can all be set to be triggers. Triggers by definition are not solid. Material. There are materials. What is the center? What is the center of the object for physical calculations? What is the radius, height? You'll see different properties here. These are capsule properties. You'll see box properties, sphere properties in that place as well. So mesh colliders. Mesh colliders use the actual 3D mesh of the model to form the collision against, and this is. Use this to your advantage, and you can use this to your disadvantage. Performance issues can arise because each polygon has to be checked. And there has a severe limit on the number of polygons allowed, and there are better practices and performance using multiple primitive colliders than the mesh collider. Now that's not always the case. Like we're talking, if we were building a target board for like axe throwing or archery or a gun range, you might want to build a couple simple meshes that represent the rings, the center and the rings of your target. And by doing that, you could get better, and then use the mesh collider. Again, you're using it in with models that are not. We're not talking about cinematic models here. We're talking like mesh. We're talking about 100 vertices as opposed to 10,000 vertices or 1,000,000 vertices. So again, you need to, when you're using the mesh collider, you need to know when and why you're going to use that particular collider.
That's wrong.
What's up?
Can you give examples on what kind of stuff that would need a mesh collider, like a player or like
A ramp,
stairs?
a ramp. Like we used the mesh collider in our first lab before the ramp.
Right.
The player would not be using the mesh collider. The player would probably be capsule, or multiple. Like if you wanted to get even further, would have a generic capsule for basic hit detection, and then more colliders to define like thigh, calf, foot, hand, forearm, upper arm, torso, head, belly.
So mesh colliders are just for like ramps.
These are special cases. Physical materials, basically, you can. This is something we're not going to play with physical materials in this lab, but like if you wanted to like have players move across like ice, then a physical material would be what you'd need to set up. I'm not going to go through those particularly. Collider. So when we're dealing with collision, whereas on collision exit, on collision stay. So solid object has hit something else. Solid object has stopped colliding with something else, and on collision stay is still hitting something on every frame that it's colliding with. We're going to use mostly trigger, so it would be on trigger enter, on trigger exit, on trigger stay. So something is entered, something is exit, something is inside the trigger still. And we are getting back, and this is the thing, we are getting back the other collider. So again, we're dealing with again, the system is two colliders, one of them has a rigid body. A is inside B. A is the trigger. A is saying on trigger enter, so B has entered A, the trigger. On trigger enter is going to tell us what component piece has come back. Now, for our purposes right now, we're going to be dealing with simple objects. But within a week or so, we are going to deal with more complex objects. And you could have multiple collision detections based on multiple collision pieces. That's very possible. So I have a trigger, and the collision method ultimately is going to be other GameObject.name, other GameObject get component type. So one would be or GameObject.transform. But like one of the things that we'll be doing is that we'll be getting like a script. So let's move on. All right, let's jump into Unity. Close. So let's grab the package. Have I downloaded the package? No. There we go. Okay, let's jump into Unity. Risk. So I've downloaded the package already. Clear, don't care. Project. All right. So I'm taking my package, dragging it right into Unity. And it's going to give us a couple materials. And I'm going to import that. And I'm going to make a new folder called soccer. Okay. And I'm going to just make a new scene. Basic built-in. Okay. So the first thing is that the soccer. So there is a open area arena prefab. Just drag that into the scene. And I'm going to open it up into there is a directional light, and so I don't need I didn't need anything. Make sure this is at 0, 0, 0. And I'm actually going to make this 0.5, 0.5. I'm actually going to make it a little bit smaller. And that's basically, hey, we've got, if I press play right now, it's like, hey, it's everything we need to see. I'm going to go in and I'm going to my main camera. And I'm going to bring the size down to, I'm going to move my game view so I can see. Try 12. Yeah, 12 works fine. So I've got more in view here. And I'm going to go into my soccer folder. I'm going to type, I'm going to make the level soccer. All right, there is a soccer net. If I go to the scene view, that'd be helpful. And I'm going to rotate, I'm going to put this at 0, 0, 0. I'm going to rotate this 90 degrees. What was the question? I can't hear you. It'll be fine. I'm going to duplicate it, and then this is going to be negative 90, and this will be on the positive 14. So I will actually, well, I'm actually going to delete this one. So that's how that will be set up eventually. I'm actually going to delete this. I'm going to actually, because I need to do work on this soccer net first before I can duplicate it. All right. I'm going to go in here. I'm going to make a scripts folder. And in here, I need three scripts. All right. First one is going to be the rigid, rigid body mover. I need a script for the soccer net. And then I'm going to need a script soccer ball. All right. So let's build the soccer ball. I'm going to go in. I'm going to create a 3D object. It's going to be a sphere. 0, 0, 0. Move this up 1. And this is where I need to add a component of the rigid body. Collapse that. And I'm also going to give my soccer ball the script, the soccer ball. That's pretty much all I need to do. So I just needed to say this object is a physical object. I need to give it the rigid body so it will move that way. And we press play, you'll see it will drop into the scene. No, I don't have a soccer ball. I'm going to go in. I'm going to create another folder here, materials. Nope, that's delete. Create a folder. And I'm just going to move these into that folder right there. Okay, just some cleanup. All right, so let's take a look at the soccer net. And for our purposes right now, what it's missing right now, I mean, it has collision, but what we need is another, I'm going to add, I'm going to add another, for our purpose, going to add a 3D object. I'm going to add a cube. And this is going to be the collision. And for our purposes, I'm going to add the soccer net. So this is one way we could do this. The other way, So basically, this object is basically acting as the soccer net collision area. The way that I think this, so I'm going to remove these components. Let me see, delete. The other way we could have added the box collider here. In fact, this is how the script the soccer net here, and they've been so for the box collider now we would change the size. I believe the X is 8, the Y is 6. No, I believe it's 4, and the center got moved up 2, and then the Z is 6 in this case. Is it 6? No, it's like I believe 3. Yeah, three will do our purposes. So you can I know you can barely see it, but we've created a collision. Again, we want to also turn it on as a trigger. So we've added this collider here, and we made it a trigger. And this is important. Basically, the script that working with a trigger, the on trigger enter relates back to the object that it's on. So let's bring up the soccer net, and we'll bring up the soccer ball. All right. So here's the scripting we need for the soccer ball. We don't. So what's going on? What are we doing here? In our case, we have defined the soccer ball as an entity, and the script at its root is defining the entity. We don't need anything else. There is one. There's some scripting here. It's on start. Basically, we want to know vector 3 start location quaternion, which is the structure for rotation. Start rotation, and these should be starting with lowercase s's. And this is getting basically start location is equal to game object dot transform dot position. Start rotation is equal to game object dot transform dot rotation. There is no update, but there is a public reset object, or just reset. Is it yelling about it? Public void. There we go. And I'll just do reset on it. Nope, I'm going to use reset object. Yeah, I think reset is declared somewhere else. But essentially what we want is game object dot transform position is equal to start location game object dot transform dot rotation start rotation. Now it is a rigid body, so we want to do a rigid body, which is called RB. RB is equal to game object get component of the rigid body. Go back to Unity just quickly. And why we need this is rigid body dot angular velocity is equal to, and this is a vector 3, so will be a vector 3 dot 0. All right, angular velocity. This is the rotation. And then RB linear velocity. That's the movement velocity, and this is going to be vector 3 dot 0. This is the line of code that needs to change. This was just velocity previously. It is now with Unity 6 now called linear velocity. So I got to update that one slide to reflect that. But this is all that the soccer ball needs. Just it's not really doing anything. It's just we can reset it. It knows where it needs to go when it starts up. SoccerNet, and pretty much everything that SoccerNet doesn't need anything to start. Doesn't need the update. There is. We can have we'll make it public. Integer int score, set that to 0, public int team number, set that to 0. Yeah, I mean these are just like utilities. We're not, and then ultimately is going to be on trigger enter. Is everything's going to happen. So the first thing that we can do on other is the first thing is check if other is a ball. And that's really then, so we're going to make a soccer ball, so other game object get component. You can see with other, I can go to the game object that it's on. In this case, it's going to be soccer ball. So here we are asking for a script that we created. And I'm going to hit return. This is not necessarily you do this. This is just basically because I'm on the projector and I need space. But the next thing I'm going to do essentially is if ball, if I don't have a ball, it's not a ball. This is where I can say, hey, debug.log. No, it's not where the ball is. It's basically other.name, and you have a space there. Is not a ball. And then I'm going to do return. And I'll end the function early. So if I get past this, other is a ball. And so, well, the first thing that I'll do is that now I have that reference to the other script. And I need to go check the other script quickly. It is reset object, okay. Oh, no, it's not other. I want the ball. There we go, reset object. So I can reset the object. Let's say score plus plus. And then we can do debug.log team space plus team number plus score. And this is a hack. In theory, I should be doing toString here. I'm going to show you. Like in theory, I should have this, but C# will do that toString automatically for you with the plus sign. It's a hack. They recognize it's a hack from Java, but use it to your advantage. And that is what we need for the SoccerNet. Again, this is I hit something, check for something. I'm trying to cast, like, get the component. I'm trying to cast something to something. I'm checking if this, again, this is how I'm checking this is the ball. And I'm going to here. And I'm going to bounce back to Unity. And I'm going to press play. And I'm going to go back to my scene view. I'm going to just grab the ball. Because right now I don't have anything else. And I'll bring that to the console. I'm going to drag it in. And you see that Team 0 scored 1. And I think this is because I'm dragging it, so I'm getting multiple scores at the same time. So I'm going to stop. All right, so we know that this is working. So let's now go and go to our rigid body mover. All right, let's go back to our scripts. Go to the lab, the smooth movement, and let's make our lives easier. We're gonna grab pretty much everything in this the script file, and we're gonna go to our rigid body mover, and we're gonna paste that in. That's good. And then the other thing is that we need to add at the top using Unity engine dot input system. The first thing that we're going to do is we're going to do a public rigid. No, it's not going to be public. It's just rigid body. I can spell it right. Rigid body RB. I'll actually add this. This is. All right. One of the things I think I'm asking you to do this week is to write a public void move forward, and this is going to be a float value, and a public void rotate player. Actually, I'm going to do move player. Be a float value as well. And so we're going to grab this line of code. Actually, I'm going to grab this line of code. And we'll clearly paste that in. So it's everything here except one more thing. We're going to multiply value into this. And so what it means is basically we're going to send in a value either 1 to -1. So this up here ends up being rotate player -1. Down here, let's grab this, a +1. So what we're doing here is we're setting ourselves up to work with like a gamepad if we wanted to. In fact, I think that's extra credit if you use the gamepad. It will, again, that should be much easier, low-hanging fruit. Moving on, we can take all the movement code. And then we'll grab this line of code. And then all we have to do, again, in here is just bring that in. And we just have to do value. So moving forward, again, the up key would be move player 1. And this will be move player -1. So we're going to just save this for right now. Let's just jump in. We're not done yet. We're actually going to, we haven't used the rigid body yet. In fact, we'll do the RB is equal to game object, get component of the rigid body. We'll change this in one moment. Let's just go back into Unity for one moment right now, and let's bring in, go to our project. Let's go to our common assets, prefabs. We'll bring in, this version of it. And I'm actually going to make a empty parent. And the reason is that essentially what I'm doing here is I'm saying is that this is my player model. And this is the player itself. So for our purposes, I'm going to go right ahead. I'm going to add the rigid body. And go back to our soccer scene. And I'll add the rigid body mover here as well. Now, we're not actually using the rigid body as of yet, so let me just remove the component just for one moment. Let's set this 0, 0, 0, and then I'm going to move this to the right. And it should be -90. So I'm looking forward. And make sure I'm in my local space. So I'm looking down that way. And I'm going to press play. I'll move forward. Where did I put the script? Oh, I rotated the player model. Oops, 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 oops. Oops, oops, oops. This is wrong. Player 3, 90, -90. There we go. Press play. Okay, so here we go. And I'm going to crank this up to 10. And right now, I am phasing through it. And that is, I think, partly because I don't have, let me check my player model. Let's just check these guys. Capsule, no, yeah, I don't think because I don't have a, so let's not worry about that for one moment. Let's add the rigid body, and let's go in and actually now change this. So we don't need to worry about setting the location. It's going to be all we have to do is our rigid body linear velocity. Now, it's still going to be equal to our value times our game object transform, our move speed, but we'll take out time delta time in this case. And this will be one line of code. So it's RB, our rigid body reference, linear velocity. Again, you will see in older code, older examples, this being just velocity. This is a new change in Unity 6. So it'll be value times game object forward, move speed. I'm going to save the script. I'm going to go back to Unity now. I'm going to close Hub because I don't need to open. I'm going to press play, go forward, and boom. I have a soccer player who flops.
Whoops.
Oops. Why is that? Again, this is under the constraints. because its rotation is not being frozen. So freeze all the rotation. I also am going to freeze the Y value. And now that I've done that, I can press play. I can go forward, crank up my move speed to 20. See, there is, and you can see now, and you can see that now that is now operating correctly because I'm not trying to drag it in the editor. All right, now that we've got that, let's go back and let's go grab our SarkerNet, and we'll duplicate this. So this will be SarkerNet. So the SarkerNet team 1. And I'm going to duplicate this. And this will be SarkerNet team 2. Again, I'll make this a positive 14 and a negative 90 to flip it around. So it's already set up. I'm going to go in the SarkerNet, and I'm going to give the team number this 2 and put in team number 1. I've done Boolean team A, team B, but I'm going to go with the float. Because in theory, like if I stretch this to being a square, I could have 2 more teams. And then I'm going to press play. And I'm going to stop because my player is slow. I am going to go in and crank this up to, I'll go 20, what the heck. See, boom, boom, you can see cube. So it's not a ball. You can see I'm going back. And I'm lined up perfectly, so this is why I can do this. So, things that we can now do. So, cool, we've got a rigid body mover, but this is a soccer game. Let's get another player in. So let's start by, I'm going to duplicate, so this will be player 1. I'm going to duplicate it. This will be player 2. I will give it a negative 3, and I'll give it a positive 90 to flip it around. Next thing, I'm just going to go into my project, my common assets, and I will make 1 red, 1 blue, there we go. So I've got 2 different players. So you can see I've got, if we zoom in, you can see the visors basically. Stop. All right, so the next thing that we need to do essentially is down here in the rigid body mover, we need to do a new get input. So we need to, so the first thing is up here, we're going to add in a public float input number, actually an integer. Set that to 0. And then we can jump down here. So we're going to copy, so this will be get input player 1. We are going to write a new void get input. And there'll be an int player, sorry, actually player input. So we can copy this now. Get input player 2. And this will be the IJKL key. So this is going to be K, D is going to be L, and the A's end up going to be a J. So now that we've got these two, basically, essentially what we're going to do is if player input number is equal to 1, get input player 1. And then we'll just do another if statement. And actually, we'll do a return. If player number 2, get input player 2, return. Okay, I am going to do one more ahead of us. 0, get input player 0, and I'm going to I'll make it here. But this is essentially going to be 0. And I'll say this is gamepad support. A hint of where you could go with this. And I'm going to save this. We'll go back to Unity. All right, so we'll go to player 1 and make sure that there. Oh, and I forgot to make the player number. Oh, there we go. This is I forgot to put the player input number. So now that the script will compile, player 1, I'm going to give it a 1. Player 2, give it a 2. And you can see. Because of my scale, I'm scaled in. And I'm basically like a rocket ship at the moment. So one of the things that we can do, let's go back to the after get input. What we can do is we can say is RE linear velocity is equal to vector 3.0. And that should slow us down. Of course, now that I've knocked it that way, I've made this game. Oh, so it's not bouncy, but one of the things that just happened is with the soccer nets, the size, I was able to touch outside.
And you still got in.
I still got in. I want to do like 7.8 or 7.5. So I want to be on the inside of that. I don't want to be pushing outside. Again, I got a little bit of a lip out here. That's perfectly fine. It's a bit of buffer. So. So that's pretty much what I'm looking for out of the lab this week, is that you can push the ball around, get it into the net, net recognizes the ball, resets it, add to a score. Again, here's my console right now, team 1, team 2. Any questions about this lab, what we need to do? All right, I'm going to stop the recording here.